So volumes, a nice mandatory data center picture. Volumes can be used for many things. We saw like a kind of first approach to volumes, which is, oh, let's map a directory from the host to the container for development purposes. But volumes can also be used when you need to bypass the copy and write system because you need I/O performance. When you read or write in a container, remember there is that copy and write mechanism, which I tried to explain with like the tracing paper metaphor earlier. So this extra copy and write layer can have a performance impact. There is a huge, it depends here, it depends on the workload, it depends on which file system you use and which storage driver you use, etc. So 1 million parameters. But what is sure is that if you are using a volume, like let's say you're running a MySQL database. So MySQL stores stuff in varlib MySQL, if I remember well. So if you do a -v / some path on my host / varlib MySQL, then MySQL is going to read and write on a volume mapped to the host, and your I/O performance will be native I/O performance because you're bypassing this whole copy and write thing. You're decontainerizing I/O in a way, a little bit like the --net host option was decontainerizing the network. So that's one thing that volumes can be good for. Volumes can also let you share directories or file between containers, and we are going to see some examples of that. So there are multiple ways to declare volumes. When you write a Docker file, you can declare a volume, and when you do that, for instance, volume /uploads here, it means that directory is going to be a volume. So you can wonder, okay, but if it's a volume, what will be the path on the host? The path on the host is going to be automatically generated by the Docker engine when the container starts. So there is a, in the Docker secret stash, somewhere in /var /lib /docker, there is a directory that has all the volumes that have been created that way. So when you create a container from an image that has volume /uploads, then a directory will be created somewhere on the host and will be mounted to /uploads. You can also do that explicitly with -v. So we've seen -v with path on the host, -v path on the host path in the container, but we can also just put the path in the container, and in that case, some path somewhere on the host will be automatically allocated. Okay. I like that example. So here I'm going to use, this is using web app, and there is no real image called web app. No, this is just missing the name of the image, but we're going to fix that example. So there is a Tomcat official image, and it's putting the logs in /usr /local /tomcat/logs. So I'm going to run, let's see, so docker run --name web app -d $P -v /user /local /tomcat/logs, and I need just to add the image name, so Tomcat. Interestingly, we can see a bunch of already exists here. So instead of pulling the whole stack of layers, I only needed to pull a few layers. This is because they share a common ancestry with the Elasticsearch image. So you can see that this layer thing is already kind of giving us like benefits. So my Tomcat thing is running. I'm going to use docker ps-l. It's running on port 32772, so let's connect to it, 32772. Yep, that's a freshly installed Tomcat, wonderful. And now the logs are on a volume, but we don't know exactly where on the machine that volume is. But what we can do is use a special option called volumes from, which means reuse the volumes of another container. So docker run -it or -ti, same thing, -- volumes from web app Alpine. So I mean a completely different container, right? It's not the same network stack, it's not the same image, etc., etc. But it's the same volumes, which means I can go to wherever my logs were. So user local Tomcat logs, user local Tomcat logs, and that's the logs of my Tomcat container. So I can do a big tail here, reload that, and at some point, I think, yeah, they don't show up immediately, but they can, yeah. I don't know why there is a delay. I don't know where the buffering is. So that gives me a way to share a directory between containers. These volumes exist independently of containers, so that's like, in practical terms, it means that if I remove my web app container, these log files will continue to exist. Let's see, docker volume ls. I have a bunch of volumes. I would like to know which one has my logs. So I'm going to do docker inspect on the web app container. And I need to find the volume section.
Very top.
Yeah, I was expecting to see like there it is. Mounts, volume, name 915f, blah 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 blah. And if I do docker volume ls, I will see one that is 915f, etc., etc., etc. Good. So now I do docker rm-f web app. So I destroy my Tomcat container. So now if I reload, it's telling me nope. But my volume still exists. So if I want, I can do something like docker run -ti alpine -v. And here I put the name of the volume, so you have to copy paste the full ID, :/logs. And that's a good example of the rule I said in the beginning. The options, like the Docker options, have to be before the image name. And here it's complaining because I was trying basically to execute the -v command in the Alpine image, which doesn't make sense. So I'm glad we're almost done because I'm doing lots of typos. Alpine, right. So now in this Alpine container, I can go to /logs and I have my Tomcat logs. So even though I destroyed the Tomcat container, I still have this volume with all the precious data on it. So I'm fine. Okay. If I don't like those super long IDs, I can create my own volumes just fine. So that's what we do here. So docker volume create, how do I call that? Web apps. Then docker volume create logs. And then I'm going to start a new instance of Tomcat using these directories. Okay, so since I have to confess that I'm not a super huge Tomcat expert, so I had to kind of figure out how to mount these things in a way that would make sense. So I'm going to expose that Tomcat instance on port 1234. Then I'm going to put a couple of -v options. So I want the logs volume to be mounted on USR local Tomcat logs. Is that right? Yes, USR local Tomcat logs. And I want web apps -v web apps to be on USR local Tomcat web apps. If you're not familiar with Tomcat, well, first of all, welcome to the club. And my understanding is that this web apps directory, you're supposed to drop jar or WAR files there, and Tomcat detects them and then deploys them. But you can also put like static files there, and Tomcat will happily serve them. And those volumes, like logs and web apps, are currently empty. Like I just created them. When I do something with Docker volume create, it's empty. But things are going to get really interesting in just a moment. So I want to execute Tomcat. Perfect. Now I go to port 1234.
Needed 80, not 80.
Oh yes, absolutely. Thank you. So okay, since 1234 is now taken, I'm going to go on 12345 on port 8080. So 12345, and I get my Tomcat hello page. Great. So now I want to have a look at this web apps volume. So I'm going to create like docker run -v web apps :/web apps -ti alpine. And I go to this web apps directory and I see a bunch of things. Even though I created that volume just a few minutes ago and I told everyone it's going to be empty, and it's not empty. So what's going on? There is a mechanism in the container engine so that when you create a container that has volumes, if those volumes are on top of a directory that is not empty, so that's what you see here, that's basically the content of the web apps directory in the Tomcat image. So if the volume is empty, then the content of the directory and the image is going to be copied into this volume. So instead of kind of masking my web apps directory with an empty volume and an empty directory, the engine copied that directory into my freshly new volume. This only works if the volume is empty. So for instance, if I do like docker volume create web apps as well, and then I like mount that into an Alpine container, I go to my web apps directory, it's empty. I'm going to create just a small file here. Then I exit this container. So now my volume web apps as well contains just this one file, and I'm going to run another copy of Tomcat on port 23456.
You keep running these containers, aren't you? Like now inside of a container, inside of a container, inside of a container.
No. I'm not in nested container. Sorry, I forgot a bunch of times to say, and now I'm exiting the container. But basically, each time that you see this fancy prompt coming back with the node IP address in red and this and etc., each time you see that, it means I'm back on the host.
How are you getting back?
Oh, I think I hit Control D.
Okay.
That's one case where being lazy doesn't help, because if at least I were typing exit, you would see I'm exiting, but I got the habit of doing Control D, and when you do Control D, that's end of file. So the shell running in the Alpine container is like, oh, end of file. I guess that means that guy is gone, and so it exits, and the container just exits. So web apps as well. So I'm creating a new Tomcat container, but with this time it has an empty web apps directory, and normally, I'm getting an error because this Tomcat failed. I think it failed to start. I'm going to look at the logs, but I guess I'm just getting a 404. Like if I do a curl here, I'm getting a 404 because the web apps directory is just plain empty. So I'm all this to kind of show, okay, I created an empty volume, and since that volume was empty, the container engine copied the content of the directory in that volume. So if I go back to my web apps volume in my Alpine container here, that's the thing served by my other Tomcat, like that one. And I can go to the root directory, and I can edit a file here, and I can put jromos here, and now it's showing up here. All right, that's the point always when I think, oh, I should have kind of explained what are the interesting things we can achieve with that, because usually at this point of the afternoon, people start to wonder, should I be listening to this? Or, so the big idea behind that is that I have my application server, so in that case Tomcat, and it's sending logs to a directory. So I can have an agent, like it could be Splunk or it could be anything like that, that would read these logs and send them somewhere. It could do anything fancy with these logs, and it would do that outside of my Tomcat container. So perhaps I have some really fancy thing that is greping my logs, and if it finds some given pattern, it's going to restart the application or whatnot. That logic can be in a different container, so that if I'm just working on the web app, I don't have to stage up everything else. It also means that I have my web application server, and maybe I want to drop jar files or assets or update things, etc. I don't have to do that in the container itself. This container can serve things off a volume, and that volume can be managed by a completely different application. So if I kind of time travel back to the 90s and I'm doing PHP 4 and I have like a container with PHP 4, I can have another container with an FTP server, and now I can update my PHP 4 with FTP, like, yeah, all styles cool. To be the more realistic scenario, it means that if I'm serving some application code and I want to implement a PaaS-like scenario, I can have a container that has a Git server, for instance, and I can Git push to that container, and then that container is going to take the code, do some things, and drop it in another volume. All these kind of scenarios are possible. Right, managing volumes, migration with volumes from, well, that's nice, but we can skip it. So since when we remove a container, the volume is kept around, how do we get rid of volumes? Like, what if I have this volume with 100 gigabytes of crap and I need to get rid of it? Well, there is Docker volume RM. There is also, I think we can do Docker RM-V, and when you do that, it means also remove the volumes. And there is also a command called Docker system prune, which does a bunch of garbage collection and bookkeeping. So it's going to remove the images that are untagged, it's going to remove stop containers, it's going to remove volumes that are not in use anymore, etc., etc.